start our discussion regarding the network, it is very mandatory to know about the rules of communication. The basic rules of any network is you have to identify the sender or receiver, common language and the grammar so that sender can understand receiver. The synchronization between the speed and timing of the delivery of data, and after getting data, confirmation or acknowledgements requirement. Apart from that, there are some fixed setting of any message transfer in the network. The first is message encoding. Message encoding is a process of converting the information into another acceptable form. Next is message forwarding and encapsulation. You have to format your message in fixed form. You have to also encapsulate according to the various layers of the network. Then the third is message size. Message size is depends on the MTU, maximum transfer unit, of the networking channel. Next is message timing. Message timing has access methods, the flow controls and response timeout timing, so that according to the time we can synchronize the various events. And the last is message delivery option, which can be either unicast, multicast or broadcast. Okay, now the next is protocol. The protocols are basically the rules that governs the communication. The protocols are a fixed form of a communication. The network protocols are providing the role of protocol. It also suggests that how the message is formatted and structured, the process by which the networking devices share information about the pathways which other network, and how and when error and system messages are passed between the devices. And the last is the setup and termination of the data transfer session. So the rules are basically the copy of the human interaction rule, and all the analogy of a human communication are inherited for the network communication. To understand it, we take one example of a protocol interaction where we will see how the web server and client can communicate. So let's say it's client, it wants to communicate with the server, which is a web server here. So if client and web server wants to communicate, the client has to originate the message in the first layer called application, where it has to apply the HTTP protocol. Then HTTP protocol will be forwarded next to the transport layer, and in the transport layer it will be converted into the TCP packet form. Again the TCP will be forwarded next to the network or internet layer, which is the layer 3, and it will be converted into the IP, and that IP packet will be finally given to the network access or a data link layer, which converts it into the Ethernet frame. So here the data starts from the application layer and gradually it will move down to the data link or physical layer. If you see the protocols which govern the various layers, then HTTP is a protocol, TCP is a protocol, IP is a protocol, and Ethernet is a protocol, which are very popular and predefined protocol for the communication, and that we have to obey when we want to make our communication. The server on other side only understand the data if it comes in this format, Means if it is coming into the HTTP, TCP, IP or Ethernet. Otherwise, the web server cannot understand it. So that's why the protocol is important. Now we see about the entire protocol suites which is available. So as we discussed in the last slide, the application layer offers the DNS, BOOTP DHCP, SMTP POP, IMAP, FTP, TFTP and HTTP protocols. Now these protocols you have to use according to your application requirement. If you want the name system, then you have to use DNS. If you want the host configuration, you have to use either BOOTP or DHCP. If you want to prepare the email application for you, in that case you have to use these three protocols, SMTP, POP and IMAP. And finally, for the file transfer, you have to use FTP, TFTP, and for web, you have to use HTTP. So it's very popular and very well known protocols available in the application layer. Okay, now next is a transport layer where you have the UDP and TCP, the two variation. The TCP is reliable, UDP is not reliable protocol. So accordingly, you can make the choice either to use UDP or a TCP. Then you have the internet layer, sometimes known as a network layer, where you have the IP protocol, ICMP protocol, various routing protocols, the NAT protocol, which is network address translation protocol. So these all protocols are part of the network layer or internet layer. And last is the network access layer, which is a data link layer majorly, and the physical layer. So here you have the ARP protocol, point-to-point protocol, Ethernet protocol and interface drivers. So this is again the protocols which are in the data link layer or physical layer we are using. Now next we talk about the reference model of the network. Network has OSI reference model, which is very important to understand if you want to understand the computer network. So OSI model basically has the 7 layers. It starts from the physical layer, it ends with the application layer. Physical layer is basically deal with binary, means the physical medium or the Wi-Fi medium of a communication. The data link layer is dealing with the frames. So all the data converted to frame is tackled by the data link layer. The network layer is taking care about the packets, the transport layer taking care about the segments, the session, presentation and application. These three forms the application, presentation and its session requirements. The OSI reference model is actually provides the list of function. It describes the interaction between the layer. So whenever you prepare any data, let's say you prepare some data here, it will be forwarded to the, it will be forwarded to the transport layer. Then transport layer will add something. Again you forward that data to the network layer, it adds something. Again you forward the data to the data link layer, it adds something. So this addition is converting your original data into some fixed format according to the protocols which are using. Let's say in application layer, if you are using HTTP, then it will be converted in transport layer either UDP or TCP. Then that UDP or TCP will be converted into the IP packet, and that IP packet will be converted into the data link layer into the frame. So this is what happens. Everywhere the concept of encapsulation will be there. The data will be added when it will be going down from application layer to the physical layer. And the size of your data will be increasing when it will reaches to the physical layer. Okay, now if you map your OSI model with the implemented model or the recent model of the internet, which is TCP/IP model. So the TCP/IP model is actually the real-time implemented version of the OSI model. OSI is just for the reference model. Well, if you want to implement it, then you have to convert it into, you have to think about the TCP/IP model. What is the difference between OSI model and TCP/IP model? That the first three topmost layer are combined as an application layer, because logically you cannot divide the session layer from the physical and physical from the application. These three are always together. So as an abstract view, we are combining all three into the application layer. Then transport layer as it is, we use network layer as it is, we use from the reference model, while here the data link layer and physical layer, which is again not dividable, we are combining into the network access model. So now TCP/IP model, if you see, you will find only 4 layers, while in OSI model you will have total 7 layers, right? So that is what the difference between the OSI model and TCP/IP model. All the communication in the network definitely follows the TCP/IP model. Without following the TCP/IP model, the communication cannot happen. Okay, now we see about the data encapsulation. As I mentioned, when you have the data in the application layer, when you forward it to the transport layer, it will convert it into the TCP. It adds some header of a TCP here, and your data will be converted into the TCP segment, which is very important to understand. It's now become segment. Then TCP means the transport layer forwards it into the network layer, and the network layer will add the IP header so that it will be converted into the IP packet. Finally, when your network layer will forward the data into the data link layer, then it will be converted into the Ethernet frame with the help of Ethernet protocol. So here you have to understand very clearly that data is sometimes become segment, sometimes become packet, and sometimes becomes frame according to the location of the layer. And finally, when you send the data from the physical layer, then it will be converted into the pure binary and will reaches to the web client or the other computer. So this is the main concept of the layering. At last, at the physical layer, you have the binaries. Okay, now next we discuss about the data access. Data access is basically to access the data from the other computer. So let's say if we have to access the data, or if you want to contact the other computer, in that case, what are the addressing requirement that we have to specify? So the first addressing requirement is at the network addresses. At the network layer we have to provide it. It includes the source IP address, it includes the destination IP address, so that it can reaches from the source to the destination network. Here the IP address will give you the idea of the network, whether your host will belong to the same network or they belong to the different network. Okay, now after it, there is another requirement, which is data link layer addresses, which is actually termed as a MAC address. So it defines the source data link address, destination data link address, and actually the MAC address is residing into the NIC card, which is a hardware in our computer. Okay, now devices can be on the same network or devices can be on the remote network. So accordingly, we have to specify their addresses. Now let us understand that figure. In upper layer, like the application, you have the encoded application data. So this is what the application layer. Then when you move down to the transport layer, you require the port addressing, which specify on which particular port number the process is running in the computer or in device. Then in the network layer, you have to specify the logical network addresses, which is actually the IP addresses. Then in data link layer, you have to specify the physical addresses, which is a MAC address of the computer. And finally, into the physical layer, you have to think about the timing and synchronization of a bit. The logical IP address is of 32-bit and the physical MAC address is of 48-bit. Logical IP address is changeable, is updatable, so whenever you want you can update it. The physical MAC address is not changeable or updated because it's available on the NIC hardware. So it's a hardware address, we cannot change it. Client and server at the same time. What are the advantages of the peer-to-peer? That it will not constrained to the centralized behavior. So there is no central point of a failure kind of thing will happen in the peer-to-peer networks. But what is the disadvantage at the same time? That security point of view, if you want to imply the security, then you have to imply the security in all the nodes, where here it is possible in the client server that security can be put to the file server, majorly on the servers, so that it can be automatically implied with the client. So both the architectures, either it's a client server or it's a peer-to-peer, are having their own advantages and disadvantages. Okay, now next we clear the terminology about the LAN, WAN and Internet. The LAN is basically a local area network, WAN is a wide area network, and the Internet is a globally connected network. But before we go into the detail of LAN, WAN and Internet, the first thing is the basic network components which we are using in LAN, WAN and Internet. So let's say the first component we introduce is the end devices. The end devices are the devices which are connected through the networking devices like switch, hub or router. So any computer, any handheld devices, any smartphone, any laptop are the example of end devices which directly user uses and to which user interacts. It can be either source or destination. So majorly the traffic flows from one end device to another end device. So the device which sends the traffic is known as a source device, and the device which receives the traffic is known as a destination devices. We have to also name some end devices either through the IP addresses or through the MAC addresses. We can recognize them. After then, the next category of the devices is intermediary networking devices. So in this category there are three major components. You can use the switch here, you can use hub or you can use router. What it does, it connects the multiple individual networks to form an inter-network. Means it connects either the various devices or it connects the various networks. It connects the individual end devices, it ensures the data flows across the network, and it ultimately provides the connectivity. Then the next category of a network component is a network media. Means which channel of communication we are using in network media. So as you can see, these three channels we broadly use as a network media. Your channel can be a copper cable, your channel can be a fiber optic cable, or your channel can be a wireless channel. So these two, copper and fiber optic, are considered as a wired network media where you have the physical connection of the cables, and this category is actually the wireless, through which we are providing the connectivity to the user through the Wi-Fi. So network media means this all provides the pathway for the data transmission. It interconnect the devices, and the three types of broadly used media are given here. Now if we see these three category, copper, fiber optic and wireless, then the speediest technology is the fiber optic, and after that there is a copper, and the last is the wireless, which is having very limited speed. The fiber optic is very speediest, so you can use in your network, but at the same time its installation cost is too much high. So if your project is cost constrained, so at that time major components you have to connect through the copper cable, and only the important connectivity you can use the fiber optic. Fiber optic maintenance and installation is very costly, while the copper cable maintenance and installation is very cheaper. So mostly if you see, the copper cables are used everywhere in the network. Only the important connectivity are connected through the fiber optic. Okay, now next we see the network representation, that what are the symbols which represent the network. So let's say this is the N device, this is again N device, it is interconnecting device which is router, it is wireless channel, it is printer, so N device, it's a IP phone, so N device, it's a tablet, so it is again N device. So by this way you must know to identify what are the various devices in the network and in which category they are falling. Okay, now topology in the network. So topology represents the way in which we connect our devices. So it can be either a physical topology or it can be either logical topology. Physical topology is how we are connecting the computers through the cables or through the wireless channel, how it can be physically connected. While logical topology is different, that how they are logically connected. Means in logical topology you are having the best view of a network analysis, while physical topology will give you just the physical representation. So mostly if you see about the importance, you have to focus here in the logical topologies. What is your logical topology? That question is very important. Next we clear this term. What is LAN, WAN and internet? So LAN, as I mentioned, it's a local area network. It is span across the small geographical area. It interconnects the end devices administered by the single organization and provides very high speed bandwidth to the internal devices. So if you want to connect various computer within your organization, then definitely you have to go for the local area network, which is very fast, which is local and limited to the small geographic area. At the other end you have the WAN, which is a wide area network. It is actually interconnecting the small LANs. So if you want to connect the multiple LAN, at that time you have to use a WAN, which is a wide area network. It administered by the multiple service provider, so there is no centralized authority here, and it provides the slower speeds compared to the LAN between the various LAN. Okay, now I want to clear the words like internet, intranet and extranet. The internet is worldwide connection of the interconnected networks. So in whole world you can connect to any computer through the internet. It is actually not owned by any individual or the group. It is publicly available. You just want to access it, and access can be provided by various ISPs, which is internet service providers. Okay, now two other terms like intranet and extranet. So intranet is limited for some company or for some campuses. So it is actually small geographical area. Now if you want some suppliers, customers, some collaborations, at that time you have to go for the extranet. And finally, the internet is a superset of all which connects everything. Now, next we discuss about the internet connections, from where we are getting the internet. So, internet access technologies are ISPs, broadband cable, broadband DSL, wireless WANs, mobile services, business DSL, lease lines, and metro Ethernet. So these are all the internet service provider, you can consider in that way, from where you are getting the internet. Once you get the internet from them, then you can be connected to any device in the world. But for that you have to pay some charge to them. But again, for them you have to give the data, how much data you want to access, or sometimes you have to also specify the timing, that for how much duration you can access the internet. So these are some of the criteria that you have to think when you want to buy the internet from these entities. But once you are buying, then it assures that you can be connected to any computer in the world. So internet is not free, you have to pay charge for that. Okay, now type of internet connections are home or a small office, and the second is business. So according to your requirement, you have to choose one of it, and accordingly you have to pay money to the ISP.